A warm welcome to you, dear children, to this bridge course session for class 10. Today we are going to discuss few basic concepts regarding the number system. We'll begin with the number system because number of concepts that you study in your 10th standard are based on the basics that what you are going to study in this session, children. To begin with, let me start with the natural numbers. We call them that as counting numbers even because in our day-to-day life situations we count number of objects. Therefore, the natural numbers, also known as counting numbers, denoted by the letter n, it starts from 1 or the 0. Then, including 0, the natural number becomes whole number. The smallest whole number becomes 0. It starts from 1, it starts from 0. In these two sets, we do not find any negative numbers. If we look for any negative numbers, then we have another set of numbers called integers. It starts from negative numbers, comes to 0, then it goes for positive numbers. Where 0 doesn't have any symbol, any sign, either plus or minus. 0 means nothing, therefore we need not have any sign for that. The example where we use this number line, most of the times we have used for the graph to draw x-axis and y-axis, we use this number line. Then even to check which is greater number, choose two numbers on the number line. The number which is right to you is greater number. The number which is right to you. If you choose these two, 3 is greater. If you choose these two, 2 is greater. If you choose these two, 0 is greater. If you choose these two, minus 1 is greater. On your right side is greater number. Then, we want to represent the numbers in terms of fractions, where we have numerator as well as denominators. There comes the number system called rational numbers. Rational numbers that can be represented in the form of p by q, where q is not equal to 0. Therefore, we can typically say here 0 is also a rational number because that can be written in the form of 0 by 1. Denominator is 1. The rule says only the denominator should not be 1, should not be 0. It can be 1. Therefore, 0 is also a rational number. Then, we have another set of numbers called irrational numbers. The irrational numbers which can never be written in the form of p by q. Example, root 2, root 3, root 5, cube root of 2, cube root of 3, pi. These are all the examples of irrational numbers. Then in 9th standard you have studied about real numbers. Real numbers are nothing but the combination of these two. Combination of rational and irrational numbers. Together we call them as real numbers. Examples, these are all the examples I have taken. Children, see, this is one from natural number. All the natural numbers are real numbers. 0 comes from whole numbers. Minus 3 integers. 2 by 3 rational number. Root 2 is irrational number. Therefore, this real number has all the numbers which are there in the previous sets of numbers. Now, we are going to discuss precisely on irrational numbers. Examples of root 2, root 3, root 5, root 6, etc. Then simplification part we are going to see in detail now. Besides of the number system, children, we have seen we need to know some more type of numbers that are there in your 8th and 9th standard classes, children. They are square numbers, cube numbers, prime numbers, multiples and factors of a given number. These are all known terms to you. Square number. Examples I have given. 1 square is this, 2 square, 3 square, 4 square, 5 square, etc. At least children, 10th standard children, you should remember at least 30 square numbers. It will be very much helpful for you when you solve practical sums, either it may be arithmetic, algebra and geometry. It will be very useful children, at least 30 square numbers. Cube numbers, 1 cube, 2 cube, 3 cube, 4 cube, etc. At least, at least 12 numbers we must know. Cube numbers. Then multiples of 5, example I have taken children. Multiples of 5 means nothing but the fifth multiplication starts from 5. Most of the children may do wrong this as multiples of 5 means they will start from 1. No, 1 is not the multiple of 5. Multiple of 5 means it must start from 5. Multiples of 4 means starts from 4. Fourth table. Multiples of 10 means 10th table. Starts from 10th. Then the another important term that you must know is factor. How do we define factor, children? Example, I have taken here 8 children. 8. Which are the numbers which divide this 8 completely? We know that 8 ones are 8, then 2 fours are 8. 1, 2, 4 and 8. These are the numbers which divide this 8 completely. Therefore, these are called factors of 8. Numbers which divide the given number completely are called them as factors. These are all the factors of this number. Similarly, I have taken factors of 8. 1, 2, 4, 8. Factors of 10. 1, 2, 5 and 10. This is how we calculate factors, children. Then, coming to prime numbers, another important concept under number system that you should know, children. Prime numbers. Prime numbers, children, are the numbers which have only 2 factors. Factors we have seen here. 8 has got 4 factors, therefore it is not a prime number. It should have only 2 factors. Which are the 2 factors? 1 and the number itself. For example, 2 is divisible by 1 and 2. 5 is divisible by 5 and 1. These are the 2 factors. 1 and 5. This is 1 and 11. 17. 1 and 17. All these numbers have only 2 factors. Therefore, they are called as prime numbers. Then one more interesting thing that you can find in this prime number set is all other numbers are odd. 2 is the only even number in the set of prime numbers. It starts from 1, starts from 2, children. Okay? Students may write from 1. No, it starts from 2. Its continuation, I have taken an example of a third, children. Okay? Irrational number 3 root 5. In this, 3 terms you must know regarding this irrational number. Which are the 2? 3 is given by a number, this is given by a number, and 5 is given by a name. Okay? We say this is root 5. Root 5. This is cube root. If you want to write 5 sixth root of 8. Sixth root. This is cube root. This is square root. Therefore, which are the 3 terms that you need to remember? Rational coefficient, order of the third, and radical. These are the 3 terms. Rational coefficient is which are there near to this root symbol. Coefficient. Root symbol is 3. Rational coefficient is 3. If a number is written like this, its coefficient is 1, coefficient is 1. We don't write that one, but it is understood. 1 is there. Okay? Coefficient is 1. Here the coefficient is 3. Then there is a number here which is hidden. That number we call it as an order of the third. Order. Order is 2. It is called as square root, no? Therefore 2. Order is 2. Square, no? Square root. Here the order is 3. Cube root. Then the number which is written inside the root symbol, we call them that as radical. Radical. It's a new term, children. So you must be in the position to recognize these three terms. When you add, subtract or multiply, we need to remember these things. For example, 3 root 5 into 2 root 3 comes, children, or a different number I will take, 6 I will take, children. Find the product of this. So in this, the rule is, first you have to multiply the order. Multiply the radical coefficient, children. Coefficient, you have to multiply first. So 3 2s are 6, children. Then radical and radical. Root 5 6 are 30. This is how we write. Therefore, when we multiply the surds, we need to remember which are of the coefficients, which are of the radical. Multiplication rule is you have to multiply coefficient and the coefficient. 3 and 2 coefficient. Then radical and radical. So therefore, children must know what is rational coefficient, order and radical. Then in this, children, in this irrational number, the coefficient is 4, which remains outside the root symbol, is 4. Order is 3. Radical is 7, which is inside the root symbol. So these are all the other basics that we need to know regarding this number system. Children, before we go to the simplification part, I have taken the addition and the subtraction part. Before we go for that, let us check whether we are able to place the correct sign. The most important part of arithmetic is this, children. If you are able to give the correct symbol, correct sign, then you have learned 75% of arithmetic, children. Here, let me solve this sum. This is 5th standard, 6th standard sum using the number line, integer. Plus 2 and plus 3 is plus 5. Answer we know. It is plus 5. Okay? Its representation plus 2 means always we must start doing a sum from 0. Plus 2 means 2 steps we have to move towards the right side. 1 step, second. Now we are here. Plus 3 means from there 3 more steps towards right only, because plus 1, 2, 3. This is our answer. Plus 5. This is how it is plus 5. See, for every sum, we may not be in the position to draw the number line and explain. So we must know symbolically to perform this action. Minus 1 and minus 2. Most of the children will make mistake this as minus into minus plus 3. They will write. It's wrong, children. Minus 1. Always we must start from 0, children. Minus 1 means 1 step towards left. Minus 1. 1 step towards left. You are now here, children. Now, again minus 2 means from there, minus 2 means left side 2 steps you have to move. That That is 1, again 2. Now we are here. Our answer is minus 3, children. Remember, it is not plus 3. Every time you may not be in the position to perform this. So you must know this, children. Next step, I have one is plus, one is minus, children. Plus means we move towards right side. Minus means left side from 0. We start from 0. Plus 3 means 1, 2, 3 steps we are here now. From there, minus 1. From this point, one step towards left side, this becomes 1. So our answer is this. Plus 2, children. Plus 2. When two different signs are there, subtract and keep greater number sign is the rule. Again, two different signs we have, children. One is minus 4. 1, 2, 3, 4. We are here. Plus 1 towards right side. Plus 1. So our answer is this. Minus 3. So two rules are here, children. When two same signs are there, plus and plus, add and keep the same sign. 2 and 3 is 5, keep same sign. Same signs are there, 1 and 2, add and keep the same sign. When two different signs are there, subtract and keep greater number sign. So, if you rub these two signs, the bigger number is 3. So 3 minus 1 is 2. Greater number sign is plus. Greater number sign. Okay. Greater number is 4. Its sign is this. So this is the most important part, children. If you are able to perform these signs without any mistakes, children, remember the 75% of arithmetic is over. This rule is applied in all branches of maths. So coming to simplification part, children. Here 1, 2, 3, 4 sums I have taken. There is one difference between these 4 types of sums. Look into sum 1. This is root 3. Its coefficient is, children, 1. Okay, even if it is not written, understood that we have 1 coefficient, 2. The radicand 3 and 3. Radicands are 6 and 6. Radicand P. Here the radicands are 1 is 5, 1 is 3. Therefore, 1, 2, 3, we call them as like terms. Like terms. Same order and same radicand. We call them as like terms. Remember, only like terms can be added. 2 pencil and 3 pencils. Together 5 pencils. Pencil and pencil, like terms. 1 pencil, 2 books. It cannot be 3 books. Unlike terms. That's what happening here, children. This is another example. Unlike terms. Unlike terms. Something like A plus B. A plus B is equal to A plus B only, children. You cannot write that as 2A or 2B. Unlike terms cannot be added or subtracted, children. Remember, its answer is this only. So its answer becomes 2 root 5 plus 3 root 3 only. That's all the answer for the fourth one. Remember, the reason I have taken, children, we call them, these are unlike surds or unlike terms, you remember. Unlike terms because the radicals are different. We cannot add something like this. Here, it is easy for us to do the addition or subtraction. Now, is equal to like terms. Like terms, something like 1x plus 2x. 1x plus 2x. Answer is 3x. In algebra we perform same operation we use here also. 1 root 3 plus 2 root 3 is 3 root 3. 1 root 3 plus 2 root 3 is 1 plus 2 is 3 root 3. 1x plus 2x is 3x. Similarly, here the answer is 4 root 6 minus 1 root 6. Therefore, 4 minus 1 becomes 3 root 6 is the answer. The third one is plus, another one is minus we have children. So, plus can be added. Plus 3p plus 2p is equal to 5p children. In this is equal to 5 root p minus 4 root p. Final answer 5 root p minus 4 root p will become 1 root p. Here 1 you need not to mention children. Even if you have mentioned, it's not wrong. Coefficient is 1. This is an example of unlike terms because radicals are different that cannot be added. This point must be clear children when you solve or simplify the terms like this. Copy down these children. Then now the simplification part that I have chosen here children. There are number of situations where you find sums of this kind in between the sums to solve. Therefore, you must be in the position to solve these things very easily. Root 12 we have. Again, this simplification we call them as prime factorization, dividing the numbers by prime numbers. Therefore, 12. Divide this 12 by prime number. 2, 6 times. Again by 2, 3 times. Here, the factorization stops. Therefore, this can be written as root of twice it is there. 2 to the 4 or 2 square even. 4 into 3 you can write children. 12 can be written as 4 into 3 or 2 square into 3 is equal to, we know that root 4 is 2 children. Root 4 is 2. Then the remaining of number is 3. See, 2 root 3 becomes, coefficient is 2, radical becomes 3. How it became 2? 4 can be written as 2 square children into 3. This square root get cancels, therefore this becomes 2, then remaining becomes 3. This is how in your previous classes, lower classes you have learned about this. Similarly, 32, prime factorization by 2, 16 times children. Again by 2, 8 times. Again by 2, 4 times. Again by 2, 2 times. 2 to the 4, 4 to the 8, 8 to the 16. Let me stop here because 16 is a square number. Therefore, I have stopped that. 16 into 2. The reason that I have given you previously the square numbers is this. If you know the square number part, definitely you will be in position to say 32 can be written as 16 into 2, where 16 is square number. Root 16 is 4, the remaining becomes 2. Similarly, 125 children. 125, prime factorization is divisible by 5. Prime number is 5. In 12, 2 times it is there. 2 5s are 10. Balance again 2 remains there. It becomes 25 children. 5 5s are 25. Again, this is divisible by 5 times children. Therefore, this can be written as 5 into 5, 25. It's a square number. Let me keep as it is into this 5. Now, square root of 5, 25 becomes 5 children. root remaining becomes 5. Its simplification is this. So these type of sums will be appearing in maybe in AP sum or algebraic part. You must be in the position to solve like this. 48 divisible by 2 children 24 times. Again this is divisible by 2 12 times. Again by 2 6 times. Again by 2 3 times. Now 2 twos are 4, 4 twos are 8, 8 twos are 16. Let me keep that number as it is because 16 is a square number, that is what needed. 16 into 3 into 3. Therefore, root 16 is 4, balance is 3. Okay, make a necessary pause, children, and write down these as it is in your maths notebook, children. And I will be posting you number of worksheets based on these sums, children, that what we have practiced today. You need to work out these sums sincerely, children, because unless you know the basics, it will be very difficult for you to move with the new concepts. Please learn all these concepts. Okay, do a number of extra sums, children. It will be very much useful to you. That's all for today, children. Practice well. Learn the square numbers, cube numbers, prime numbers, etc. Keep doing well, children. Take care of your health. God bless you. Thank you, children.